bonjour alors tout le monde. Good morning everyone. Alors je vais donner quelques mots sur Peng, quelques éléments de CV de Peng pour introduire sa présentation. Alors Peng Gao, c'est un chercheur et enseignant-chercheur à l'université de Syracuse à New York dans le département de géographie et environnement. Donc c'est un géographe physicien qui est formé en géomorphologie fluviale. Donc ses recherches portent sur les processus géomorphologiques à l'échelle des bassins versants, également sur le transport sédimentaire, et cela donc à l'échelle des bassins versants, mais aussi dans les systèmes agricoles. Il fait aussi de la modélisation à l'échelle des bassins versants en termes de processus hydrologiques et des transports sédimentaires, et il étudie également les structures morphologiques le long des cours d'eau, donc les profils longitudinaux des rivières de montagne. Depuis 2015, ces recherches sont axées essentiellement sur de grands domaines, donc la dynamique fluviale et les changements environnementaux et l'impact de l'urbanisation par des approches géospatiales. Et Peng, il est chercheur invité de H2O'Lyon. Il est là depuis début mi-mars. Il restera encore jusqu'à la mi-juillet avec nous, et notamment pour travailler avec des chercheurs de la communauté H2O'Lyon, notamment avec Hervé Pégué et avec moi-même également, sur les thématiques autour des rivières en tresse et notamment sous les rivières en tresse du Qinghai-Tibet plateau, dont il va nous parler un peu tout à l'heure. Et avec Peng, on travaille notamment sur des approches géospatiales. Donc, on utilise la télédétection satellite pour étudier l'évolution des rivières en tresse et l'impact des actions anthropiques et du changement climatique sur l'évolution de ces rivières dans le plateau tibétain. Donc je pense que j'ai fini. Donc merci Peng d'être là et on va t'écouter pour ta présentation.
Merci Barbara. J'aimerais remercier tout le monde de se joindre à nous à cette heure de la journée. Donc, je vais parler de fleuves tressés au niveau du plateau Qinghai-Tibet.
First, I want to give you a brief introduction of the spatial distribution of the braided rivers in the Qinghai-Tibet plateau. And then I will provide you some very detailed examples of braided river ridges within the Qinghai-Tibet plateau. After that, I will use 3 examples to introduce you the functional characteristics of these braided rivers, and this will be followed by my summaries and the projections of the future research. My talk will end by showing you some very interesting pictures of unique animals on the Qinghai-Tibet plateau. So please stay with me all the way to the end. Okay, so where is the Qinghai-Tibet plateau? The Qinghai-Tibet plateau is located on the west side of China, and it has a mean elevation about 4,000 meters, so which is why this is the world's highest plateau. And the entire area covers about 2.5 million square kilometers. However, its population density is very sparse. It's only 44 persons per square kilometer because this is not a very good place for people to live. So from the fluvial perspective, inside of the Qinghai-Tibet plateau, there are all kinds of rivers distributed from northeast side of Qinghai-Tibet plateau all the way down to the south of the plateau. So in general, these rivers can be grouped into 5 watersheds. The first one is called the Upper Yellow River, and this one actually connected to the Yellow River that passes through the northern part of the China. The second one is the Upper Yangtze River, and this one its downstream part cross all the way across the southern part of China, And the third one is the Upper Lancang River. When this river moves south, it becomes the Mekong River, running through Laos, Thailand, Vietnam, and Cambodia. The fourth one is the Upper Nujiang River. And when it moves to the south, it becomes Salween River. And this river passing through the Burma in the south of Asia. And the last one is the Yalu-Zangbu River. And this river, when it's run to the south in the downstream, it becomes Brahmaputra River, which runs through the India. So next, what I'm going to do is that I will introduce you some example braided river systems within each of these big south area watershed. The first one is the Upper Yellow River. Within this river, as you can see from this picture, there are braided rivers distributed all over the places through the watersheds. Most of them are concentrated on the upstream sections, even though you can see some of them are on the main channel sections and some of them are distributed in the tributaries. And next, I'm going to focus on two specific braided branches. The first one is called the Daheba River. It is a branch distributed in the downstream part of the watershed. It's joined directly to the main stream of the Upper Yellow River. The second one is in the upstream section of the Upper Yellow River, and it's the part of the main river. It is called the Dari Ridge. Now let's get into the first one, Daheba River. And this picture shows you the topographic distribution of the watershed that includes this Daheba River. What you can see here, you're not going to see clearly from this, but I will show you next. The characteristics, physical characteristics of this river is that its valley is formed by the very strong erosion processes because of tectonic movement. And also the braided rivers developed within this valley are confined by the steep cliffs on both sides of the river. And because of that, there are a lot of materials supplied from these two cliffs into the river. And I will show you from here. And this is the picture I show you in the kind of confluent section point between the two upstream rivers. As you can see from this side, you only see it from this picture, the mainstream, because this is a dry season. The water discharge is not very high. However, if you look up here, you see on both sides of the cliffs, they have a relatively, about the same elevation, which tells you this is the same terrace. And this braided river is actually caused by strong down cutting of the fluvial processes. Next, if we go further downstream along this river from this point to the downstream section, this is what you can see. Again, the braided river is bounded by the two steep cliffs. And the most striking point I want to make in this picture is this series of alluvial fans. And this alluvial fans actually supplied a large amount of sediment to the rivers. They really shaped the bed material distributions of this river. And this is the picture taken from the downstream part of this watershed. As you can see, some details of the particles in the channels, and also you see the main channels of the braided system. And this is at the confluence of this watershed, and the river actually joins into the main river, main Upper Yellow River. And this part is actually the main Upper Yellow River. So basically, the major characteristics of this watershed is this particle size and its distribution. And what I want to make, the point I want to make is that the particle size that you see on the riverbed here mainly comes from the two sides of the steep cliffs caused by very active hill slope processes. And this shows you how active the channel, the braided river systems itself. As you can see, this bank protection construction has been undercut by very strong, very powerful flows through its main channel system. Next, I want to focus on the second part of the ridge in this watershed, the Darri Ridge, and this is a part of the main upstream main channel. The section I'm going to focus on is the right upstream of a local county called Darri, as you can see from this image. And the picture you see here is essentially an oblique UAV picture. It shows you a quite different braided river system compared against the braided systems in Darri River. It is much more stable, and also you see a lot of bars here are covered by vegetations here. So here I shows you a close look of these bars with vegetation covered that has a relatively higher elevation. The bars with bare soils on top has a lower elevation. You can imagine during high flow, during high discharge, those bare soil bars will be inundated and also may be eroded by high flow rate. Okay, next let's go to the second watershed, the Upper Yangtze River watershed. In this watershed, I will focus on the upper part of the watershed and talk about different types of braided river systems. So overall, the physical characteristics of this part is that most source areas of these river systems are bounded by glaciers, which is represented by this red color. It just represents very high elevations. And also the alluvial valleys developed in this system are all based on deposition processes rather than erosion processes. Okay, so within this system, I want to start from this very upstream sub-watershed, which is called Buque River. And in this river, you can see its topographic distribution of the entire watershed. I will start from very south area of this watershed and to show you the picture of its south area. As you can see, it's covered by glaciers. The location where I stood to take this picture has the elevation of 5,250 meters. So this area is basically above 6,000 or 6,500 meters. The striking side is that you see that clear, like the strong, like glacial melting processes, the thick of glacier become thinner, and many parts of the hills, the mountains used to covered by glaciers disappeared. So it shows you the strong impact of climate change on these areas. Okay, when we move from this source area downstream a little bit, as you can see from here, we begin to see the formation of the braided system, but here it's still very small, not very mature, because the contributing area is not big enough here. When we move further down, as you can see from here, from this UAV picture, you can see the very well-developed braided river system. It is in this area, as you can see, the valleys becomes widening at this location. Okay, so in this close look view, you can see what the point bar looks like in this system, and what kind of the river banks of this braided river system look like here. As we move further down, as you can see, the valleys becomes wide open. As a result, you can see the braided rivers developed very well, and there are really multiple channel branches developed in this very flat, wide valleys. And you see like bars covered by green vegetation. Also, there are some bars with bare soils. You can imagine during high flows, those bars are subject to strong fluvial processes. And this is a closer view of this section of braided river. As I said just now, you can see these bare soil bars has already experiencing some erosion. When flow rate increases, and more erosion would occur along the side of these bars. Next, I will go to the other side of this area, which is called the Turtle River. And this is the opposite, and this is the Buchu side. I'm going to the opposite side of Buchu River, which is the Turtle River. From this topographic picture, you can see the valley where where this point showing you is generally wider. And because of that, when you look at this amazing picture, I mean, you can see how complicated the braided river system is here. I cannot even count how many branches in this system. So this is a really very, very complex braided river system. And here I show you some closer view. As you can see, these are the bars with bare soil, and as I said just now, these bars are subject to strong fluvial processes, mainly erosion, but sometimes deposition also happens along these bars or on top of these bars. Next, let's go to another part of this watershed, and a sub-watershed called Qinghai River. And this is its topographic distribution. And you can see like there are two tributaries joined together to merge into one, the main stream here. And the location I will show you is somewhere here. So the sediment in this position comes from this right branch of the river. The most striking feature you can see from this part of braided river is its color. It's red color, right? It's quite different from what I showed you just now within the same watershed. And the reason is because this sediment comes from the upstream source areas where the deposited sediment has this red color, and the red color is mainly caused by very rich concentration of iron element. Okay, and which is why this river, local people also call it as a red water river. Sorry. Okay, so now I was here just now, the Qinghai River. Now I move from here downstream to the mainstream section we call the Tongtian River here. Okay, in this one, I use this Google Earth map to show you this plainform structure of this river ridge section. Here, I show you the UAV oblique picture. Basically, what you can see here is that this is a braided river that is partially confined by the mountains on one side of the river. Indeed, this side of the river is actually very deep here, but it's confined by this mountain. But on the other side of the river, there's still enough space for the river to develop, to grow. Okay, from this closer look view, you can see again the instability of these bars without vegetation covered. And you can imagine a year later, if you come to the same location, you are not going to see the same sediment bars appeared here. Okay, so in general, within this upstream Yangtze River watershed, we can summarize its physical characteristics. First, the particles, the bed materials is actually formed by the mix of sand and gravels. It's mainly based on its upstream area or its bank materials. Second, the land cover is very sparse. So the percentage of land cover, vegetation cover is very, very low. Even though like in this picture, it appears like there are a lot of vegetation covers on this area. And this is just in the very downstream area. As I showed you just now, in many upstream channels, there are not many vegetation cover. And next is this braided river systems almost has no human disturbances. As such, they are almost like a pristine watershed. The last one, they all have the glacier as their source areas, so they are affected by glacier melting. Okay, the next one is the upper Lancang River. And in this river, I will only focus on the middle part of the river. And this is the picture I want to show you about the braided river system. And you can see from here clearly, there are more vegetation covers here and more point bars are covered with rich vegetation. And this shows you the close view pictures during the wet season, and you can see the density of vegetations on the point bars. This shows you the picture of the dry season. You can see many branches are dried up during the dry seasons. So this just shows you how dynamic these braided river systems. Next, I show you the Upper Nujiang River. Okay, in this river, because it's not easy to reach this river, we haven't spent a lot of time on this river. So I just show you one picture in the upstream section of this river, which also shows a braided morphological structure in this watershed. The last one is the Upper Yalu-Zangbu River, and it is located very south of the area. Within this river, you can see braided river also developed across the entire watershed from upstream to the downstream. And I will only focus on the two areas to show you. First is one of the main tributary of the Yalu-Zangbu River, which is called the Lhasa River. The second is its middle reach section of the river. Okay, so this one shows you the Lhasa River, the main tributary. It's during the dry season. And the key point I want to show you is that you can see like the impact of this road built by human beings on the river systems. And also from these pictures, you can see first, this bridge across the entire river valley. And the second, you see this very regularized, regularly arranged vegetations, which are man-made, which are artificially planted trees on the bare soil bars for the purpose of stabilizing these bars. So the point is that this river system is significantly affected by human activities. And this shows you the middle reach of Yajiang River. Again, the most striking point is this regularly distributed trees planted by human beings for the purpose of stabilize the point bars. Again, you can see from this close look pictures of these human man-made trees on the point bars. Okay, next, I want to switch to the next topic about the river functioning characteristics, I will introduce you the 3 examples of what we have done so far. The first one is in the upper Yangtze River watersheds. And in this study, we selected 2 nested watersheds. The first one is this smaller sub-watershed, and the second one is this bigger one. And within these 2 watersheds along the main channel, we selected a braided ridge from upstream, middle part, and the downstream, respectively, in these 2 watersheds, and studied their morphological changes. And from this diagram, you can see the top 3 are the results from the small sub-watersheds. This is upstream, middle stream, and downstream. The bottom 3 is from the larger watersheds. So what you can see clearly is that there are some general patterns here. Okay, before I get into that, I want to explain to you the meaning of the horizontal. And this is the ratio of water area with regards to the entire valley area. So from moving from left to the right, the ratio becomes higher, which also means the water discharge in the braided river systems increasing. So all of these diagrams shows one common feature, that is their braiding intensity, which is BIT on the vertical side, reaches the maximum value when about 40% of the valleys is covered by water. Okay, and this pattern exists regardless of spatial distribution of the rivers. Next, let's look at the sediment processes. And this diagram shows you the suspending the sediment load against the discharge, which we commonly call it as a sediment reading curve. This is for the small watersheds. This is for the larger watershed. This is the comparison of both watersheds. So what you can see from here is that actually the 2 watersheds has a very similar sediment reading curves. So that means that the sediment transport processes are very similar in this 2 sub-watershed, even though the smaller watershed is closer, much closer to the glacier source areas. So that means, that suggests that glacier melting processes hasn't been significantly affect the sediment transport processes. In summary, this study shows that overall the morphological structure of these braided rivers has remained stable over decades, regardless of their spatial locations. In the second example, I want to show you our study on in the Lhasa River, the main tributary to the Yalu-Zambu River watershed. And in this one, we focus on the downstream part of the river. Above this river, upstream of the river, there are 2 dams constructed. This downstream dam constructed in 2006. The upstream one was constructed in 2013. Because of that, we collected the data in 3 time periods, before 2006 and between 2006 and 2016, and after 2013. Okay, we also divided this study area into 4 ridges based on the dominant human activities. And the first one is ridge A is closest to the downstream dam, and ridge D is close to the ridge, the confluence point. This table basically just shows you different types of human activities, including farmland, afforestation, urban development, and mining. Okay, and on top of that, it's the impact of the 2 dams constructed on upstream of that. So I only want to focus on part of the results, which are showed marked by this yellow circle, and these points represent the temporal changes of active channel weights and breathing intensity of ridge A through the 3 periods. the idea of this is that it shows that either what you can see is that from the early stage to the later stage, the both channel width and intensity, breathing intensity slightly decreased, but this decrease is not statistically significant. So the interpretation could be first, that means this breathing ridge has a very fast response to the dam construction, because the dam was constructed here in this period and in this period. Or the interpretation could be that the morphological change of this ridge is not affected by the dam construction, rather it affected by farmland, because the ridge A has the highest percentage of farmland. Our hydrological analysis actually confirms this second interpretation. Next, I want again just to show you the example, the ridge C. As you can see, with regards to urban development, ridge C has the highest percentage of urban development. So the channel widths actually are generally high, do not align with the channel width of other ridges. But the breathing intensity actually fall in line with the trend of other ridges with regards to the percentage of urban area. And for the farmlands, you see some opposite situation. The breathing intensity actually does not follow the trend, but the channel width actually follow this trend of the change. The point I want to make here is that actually the response of breathing morphology to the different types of human activities are very complex. We really need more information to separate the impact of different types of human activities to the river morphologies. And this is an ongoing research we are doing right now. Okay, so the third example would be the study we did in the upper Lancang River watersheds. And in this watershed, we focus on the middle section of this watershed. And this is a typical braided river system. We divided the braided channels into two types. Flowing channels in blue, it represents the wider, larger channels that always has the water flowing through them. And the second one is non-flowing channels, which are those disconnected channels or isolated channels in red. And they typically occurs during dry season, representing the degree of connection between groundwater and the surface water. And these 5 images shows you the UAV data of the same area. Because of their high spatial resolution, we use the measurement from these 5 UAV images to calibrate our measurement in the from the Landsat data for this area. Okay, so in this diagram, you see that breathing intensity in this area actually closely related to the discharge. Here you see the temporal trend of breathing intensity over time, and also the associated peak discharges, which are in yellow, and the number of days the discharges is above a given threshold value, which shows in this triangular. We also, you can see in this one, we compare the active channel width and breathing intensity against those of breathed rivers in European alpines. And you can see in general, both width and breathing intensity are high in our study area. So we concluded first that breathing intensity was mostly controlled by flows, but in some periods it was not. And the first part is mainly from based on this result. The second part comes from this period, from 2008 to the 2010. You can see the peak discharge actually decreases. You would expect that the decrease of a peak discharge would cause deposition of sediment, which will cause the decrease of breeding intensity. But if you look at the breeding intensity in this period, they are increasing. This basically shows you complexity of morphological adjustment to the variable hydrological processes. The second conclusion, we say that braided ridge is potentially well-connected braided system with sufficient sediment supply. We argue that this is mainly because the less vegetation cover and the lower surface roughness, because we calculated the surface roughness of our study area and compared against those in the European alpines, and our values are very low. And furthermore, we showed that during the dry season, which is the spring and the fall, these two periods, the non-flow channels covers up to 30% of the breeding systems. This percentage is much higher than that in the typical European alpine breeded river systems. And when we look at the temporal changes of vegetation areas, as you can see, in the most time of past few decades, the vegetation area is very, very low, less than 0.3 square kilometer. But after 2010, it started to increase and maintains the high value. The first part could be explained by the morphological dynamics of the rivers, but the second part cannot. So we further shows that actually the temperature of vegetation growing season, which is typically summer, actually increased with over time. So we think this increasing of temperature could explain the sudden increase of vegetation after 2010, even though the early part of the period, the low vegetation was controlled by very dynamic morphological changes of the river. Okay, so in summary, braided rivers are very well distributed in the Qinghai-Tibet plateau. It is very important to understand their morphodynamic processes because understanding this would help us to understand how in the future these rivers and associated ecosystems would adapt to the climate change and the enhanced human disturbances. Second, braided rivers seem less affected by climate change.
Moins affectés par le changement de climat et par la perturbation humaine. Mais il nous faudrait plus de données, il faudrait faire plus de recherches avant de pouvoir confirmer cette conclusion. Troisième conclusion, le fonctionnement fluvial est apparemment a la caractéristique suivante, une bonne connexion entre l'eau de surface et l'eau souterraine grâce à des structures morphologiques favorables. Donc, le point que j'essaie de souligner, c'est que même si c'est vrai, la question est, est-ce que cela veut dire que l'écosystème de ce système tressé va être amélioré à l'avenir? Donc, avec ceci à l'esprit, voici.
Climate change in the future will improve the ecosystem conditions of these braided systems with more vegetation growing on bars and along the banks. If this is true, then the braided river systems on the Qinghai-Tibet plateau will become one of very few cases that shows the positive impact of climate change. Okay, I want to use this recently published review paper on the water balance in the Qinghai-Tibet plateau to give you my reasons for this hypothesis. The blue area you see is called the endorheic basin, means all the water falling within the basin will stay within the basin. The pink area is called the external basin means all the water falling within the area will flow out of this. If you look at the boundary of these two basins, you can see clearly by comparing with the boundary of the 5 source area watersheds I described to you just now. They are exactly the same. So basically that means this lower part is our braided river, is our river systems in the Qinghai-Tibet plateau. So the past study shows that actually the increase of water storage in this area is much higher than the increase of water storage in this area. And my interpretation for that is because of the percentage of glacier area cover in this lower area, watershed systems is much lower than those in this Indo-Rig basins. And because of that, I hypothesize that in the future, the increase of water discharge will be limited. This limited increase of water discharge is not going to be enough to cause more sediment transport that carries sediment left in the source area due to glacier retreat. Second, the increase of discharge will increase the base flow of the discharge in these water systems, which means it will enhance the interaction between groundwater and surface water, and which will further encourage the development of a diverse ecosystem. Okay, so as you can imagine, in that remotely located area, it's even very hard to access to these areas. If you work in that area, it's even harder because of the very high elevation and the very harsh weather conditions. However, every time when we arrive at that area, when we do our field work, we always find some fun stuff. So before I end my talk, I will show you some fun pictures. And this is Tibetan yaks. And in this picture, these two yaks are fighting with each other, but in an amazing civilized way. So they basically just push each other back and forth. If this guy wins, then they move this direction. If this guy wins, they move to the other direction. So in the periods of about 5 minutes when we watch them, these guys basically just move back and forth, back and forth. Very interesting picture. And this is a Tibetan donkeys. And these donkeys actually stick their mouths into the snow and try to find the food. And remember, this is snow happened in July, in the middle of the summer. And this is a Tibetan antelopes. This is a very symbolic animal in that area. What you see in this picture are the 4 young antelopes, and their parents are staying around that like 60 or 100 meters away from them, watching them from distance. This is a Tibetan camera. It's kind of ugly. And this is a Tibetan fox. And this guy is actually very sensitive to human beings. It's not
aux
very...
êtres humains. C'est très facile de les capturer en fait. Et voici le loup tibétain qui fait peur. J'ai pris cette image quand j'étais en voiture. Je ne voulais pas descendre de la voiture parce que c'est un loup qui se trouve dans une zone où il n'y a pas d'être humain. Donc, c'est une zone qui est assez large dans le bassin. Et voici un vautour tibétain. Donc, c'est un oiseau vicieux. Ce vautour est célèbre à cause de cette tradition tibétaine qui s'appelle enterrement célestial. Le peuple tibétain brûle les corps des personnes qui meurent ou mettent les corps dans des cercueils qui mettent ensuite sous terre. Et en fait, les corps sont transportés sur des plateformes et ils brûlent du bois pour appeler les vautours, pour accélérer la décomposition. Ils pensent qu'en ce faisant, les membres de la famille iront plus vite au ciel. Voilà, je m'arrête là. Merci de votre attention. Je serai ravie de répondre à vos questions.
Merci beaucoup, Peng. C'était riche, plein d'images, plein d'informations. Tu nous as fait voyager un petit peu. Alors là, je vois, il y a une petite question de la part de Baptiste. Je vais la lire, Peng, pour toi. How about the role of permafrost and
Et le rôle du permafrost
and the succession of freezing
et la succession de
cycles in
cycles
controlling
de
erosion
gel
patterns
pour le contrôle des
and
schémas
thus driving
d'érosion
pattern in such a high elevation environment?
dans un environnement qui est si élevé. Alors, quel est le rôle du permafrost? Pour être franc, je ne pense pas qu'il y ait un rôle considérable pour les systèmes fluviaux que je vous ai montrés. Mais cela ne veut pas dire que cela n'existe pas. Le permafrost joue un rôle, mais dans la partie plus amont du système fluvial. Mais c'est très difficile pour nous d'y aller parce qu'il n'y a pas de route et l'altitude est encore plus élevée. Donc, c'est difficile d'y accéder.
En t'écoutant, on aurait dit qu'en fait, on peut observer une sorte de gradient du nord au sud de plus en plus d'impact anthropique sur ces systèmes. Et voilà, c'est un peu confirmé. Et puis aussi, je me disais, en fait, ouais, c'est des endroits où il y a pas beaucoup de densité humaine, elle n'est pas forte, mais toutes les photos que tu nous as montrées, il y a quasiment tout le temps des présences de l'homme, des routes, j'ai vu des lignes électriques. Est-ce que tu peux nous en dire un peu plus?
OK, thank you.
Oui, merci. Merci. Une très bonne question. Donc, voici ma réponse. Alors, l'activité humaine est dans ce 5e bassin, dans cette partie du système fluvial. Il y a toutes sortes d'activités ici et ces activités vont s'intensifier dans les 5 à 10 ans à venir. Mais il y a également des activités humaines, sont relativement intenses dans la partie du nord, au niveau du fleuve Jaune, mais pour des raisons différentes, parce que dans cette partie supérieure, l'altitude est relativement faible. Et une partie de cette zone, le bassin Zoiga, dans cette partie, il y a beaucoup de végétation, énormément de végétation et beaucoup de précipitations. Donc, il y a des tourbes et il y a des terres humides. Et c'est pour cette raison qu'il y a plus de personnes ici par rapport aux autres régions. Dans ces 3 régions du milieu, il y a moins de personnes relativement parlant, et c'est pour cela qu'il y a moins de perturbations dans la partie du milieu de ce système hydrographique.
Merci, Peng. Il y a une question d'Hervé. On voudrait en savoir un peu plus sur la végétation, les plantations, cultivation de forêt. Est-ce qu'on observe cela un peu partout sur le plateau et quand ça a commencé en fait?
Très bien. Alors, je n'ai pas l'année exacte, mais la plantation, il me semble,
I believe we have some data to show that, but I don't have this in front of me. I can get that data to show you. But I think what Abby asked is the plantation in the very south watershed called the Yaluzangbu watershed. It's this last watershed here. And this is a very typical human activities happened within this watershed, Yaluzangbu watershed. And in other watersheds, we don't see this kind of plantation activities happens. Even though like in the very north part of the Yellow River watersheds, we see more vegetation cover. It's a natural vegetation cover in the breeded systems, in particular the upstream part of the watersheds, as I showed you just now in the Dari River system here in the upstream section of the river. There are more vegetations grew up here, but it's a natural vegetation. It's not a man-made vegetation.
Merci, Peng.
Thank you, Peng.
Est-ce qu'il y a d'autres questions?
Are there any other questions from the audience?
Sinon, moi, j'en ai une autre.
Otherwise, I have another question.
Par exemple, le premier exemple sur
The first example that you gave us
le Yangtze,
on the Yangtze River.
au moment où tu dis que la fonte des glaciers n'impacte pas vraiment la morphologie, mais est-ce que ça a impacté des crues morphogènes? Par exemple, est-ce que vous avez essayé de voir si en fait la fonte des glaciers, donc ça cause juste une augmentation graduelle du débit et du coup ça n'impacte pas vraiment les crues morphogènes? Je ne sais pas si c'est clair.
Yeah, I understand the point.
Oui, je comprends ce que vous essayez de dire. Alors, voici ma réponse. Nous avons tracé la décharge annuelle et quotidienne pour les 3 dernières décennies, voire plus. Donc, il y a une petite augmentation en termes de décharge quotidienne. Et cela indique que l'impact du glacier sur la décharge n'est pas très élevé. Quand je dis que ce n'est pas très élevé, ce que je veux dire, c'est que cela ne change pas le débit. On a quelque chose qui est assez paresseux à quelque chose qui est un peu subite. Et si ça se produit, ça veut dire qu'il y a plus de sédiments dans le système. Lorsque cela se produit, lorsqu'il y a une fonte, cela laisse beaucoup de sédiments dans la zone source. Donc, si cela change le régime hydrologique, on s'attendrait à avoir plus de sédiments transportés à travers le système. Et si c'est le cas, vous n'allez pas voir ces courbes identiques. Pour moi, c'est la preuve de ma déclaration. Mais bien sûr, je suis d'accord. On a besoin de plus d'études pour confirmer ce point. Se servir uniquement de cette étude ne suffit pas. Et c'est pour cette raison que j'ai parlé d'une hypothèse générale.
Ou sinon, une question un peu plus générale et un peu, voilà, qu'on pourra continuer à en discuter au bureau au cas où. Tu as parlé donc avec l'augmentation de la température et donc des meilleures conditions écologiques. Mais est-ce que c'est vraiment des meilleures conditions écologiques en général? Alors, on va perdre des rivières en tresse, donc ça sera dommage.
Je pense qu'il y a un malentendu là. L'augmentation de processus hydrologiques, et spécifiquement la décharge, est provoquée par la fonte des glaciers. Mais il y a un autre facteur dont je n'ai pas parlé parce que je n'avais pas le temps, et c'est cette petite augmentation de précipitation. Donc, cette augmentation de précipitation va continuer, ne va pas s'arrêter. Et cela veut dire que le système pluvial tressé ne va pas disparaître à cause de la fonte des glaciers. J'aurais dû clarifier cela. Donc, il y aura encore un approvisionnement en eau à ce système fluvial. Comme on peut s'y attendre à l'avenir, d'ici 5 à 10 ans, la fonte des glaciers, son rôle sera moindre et le rôle de précipitation et de processus hydrologique va être de plus en plus important. C'est ça la complexité. L'augmentation de précipitation est variable. Donc, c'est quelque chose qu'on doit étudier, ce variable-là.